The global deployment of 5G New Radio standalone has been driven by mobile broadband services, where the emphasis was put on significant high data throughput and latency performance. Therefore, most of the 5G NR standalone users require powerful and therefore complex and expensive device platforms. Wearables and a range of other new devices, both for consumers and industrial applications, do not require these advanced performance capabilities, but are still too advanced to be served by existing 3GPP technologies such as NB-IoT and LTE-Cat-M. "3GPP Release 17 has addressed this need by defining Reduced Capability's RedCap, a device capability type served in the 5G NR air interface, but with reduced capabilities, including user equipment UE simplification by changing the minimum antenna configuration, limited data transmission speed, and modulation order. Power-saving functions are enhanced for this type of devices as a result of reduced bandwidth support. These changes result in similar throughput levels to LTE categories 1 to 4. But at the same time, advanced 5G NR functionalities such as network slicing, low latency, etc. are available for RedCap users. Each addressable RedCap use case has its own set of requirements, which compared to regular 5G NR devices is less demanding in terms of data rates, latency, etc. Yet is more stringent when it comes to reduced device cost, complexity, and power consumption. In fact, RedCap is designed to efficiently support use cases whose requirements fall between the more extreme requirements defined for MMTC, UR-LLC, and eMBB. However, RedCap devices may also be suitable for moderate MMTC, UR-LLC, and eMBB use cases. For example, when comparing RedCap requirements with eMBB, UR-LLC, and MMTC use cases, the following can be noted. Data rates. The target peak rate for eMBB is up to 20 gigabits per second in downlink and 10 gigabits per second in uplink, while for the most demanding RedCap use cases, it is up to 150 megabits per second in downlink and 50 megabits per second in uplink. Latency. The target for UR-LLC is about 1 millisecond, while for RedCap use cases, it is less than 100 milliseconds for industrial sensors. However, these are minimum requirements, and it is worth noting that RedCap devices can in fact achieve much better latency than this. Battery life. The target for MMTC is 10 to 15 years battery life, while for RedCap use cases, it is 1 to 2 weeks for wearables and few years for industrial sensors. Again, these are minimum requirements, and RedCap devices may be able to achieve a longer battery life. With RedCap and its evolution, 5G can address mid-tier broadband IoT use cases in addition to the 3 key usage scenarios by using any available spectrum, both time division duplex and frequency division duplex in all frequency bands. The use cases with RedCap include wearables, industrial wireless sensors, and video surveillance. They will have different network requirements. Typical requirements for wearable devices such as smartwatches, wearable medical devices, AR, VR goggles, etc. are peak rate up to 150 megabits per second for downlink and 50 megabits per second for uplink. Battery life can be up to 2 weeks, and positioning, for example, during emergency calls. Video surveillance use cases require end-to-end latency less than 200 milliseconds 99% to 99.9% reliability, and uplink peak rate up to 50 megabits per second. Industry wireless sensors may require a bit tighter requirements, including end-to-end latency less than 100 milliseconds, 99.99% reliability, and battery life up to few years in certain use cases. In summary, RedCap introduces a completely new device ecosystem into 5G, targeting the efficient operation of lower complexity devices and use cases. Thanks for watching this RedCap microlearning, and if you want to know more about this and other 5G and RAN topics, check out our website and continue learning.